Hello, today we'll explore different computer vision approaches, looking at their pros and cons, especially for manufacturing. In this demo, we'll focus on a lamella sorting system, where we categorize planks based on detected defects. One approach is training models to detect specific defects. Once we get predictions, we use conventional programming to classify the lamella based on custom rules. For example, one model detects wormholes, another finds scratches, and the last spots empty knots. After that, predefined rules determine the final category. Another method skips detecting individual defects. Instead, we train one model to directly predict the lamellas category. Here, we just feed the image into the model, and it predicts the category. The downside? We don't see why it made that decision, making debugging harder. For larger materials, downscaling full image can eliminate small details. To fix this, we use tiling, splitting the image into smaller sections before running defect detection. These smaller image regions are analyzed separately. However, this means we lose some global context, so extra coding is needed for better accuracy. Afterward, we combine predictions from all the tiles and apply the client's rules. Now, comparing the approaches, detecting defects individually makes debugging easier and works well with less data, but it requires more coding. Direct category prediction is simpler but harder to interpret and often needs more training data. Tiling helps for large products and shares the pros and cons of the first method. We've applied these methods across different industries. Defect detection works in medical devices and aluminum profiles. Category prediction is great for PET preforms and grains. Tiling is used for bigger products like seats, lamella sorting, and textiles. The best approach depends on your specific needs. Reach out and we'll help find the right solution for you.